Today, together with Bogdan, we will solve a live coding JavaScript interview question. This is a real question one of our mentees got for a senior front-end engineer position. This is a lead code style kind of problem focused on data structures and algorithms.
Perfect. So the problem statement is that given an array of integers, we need to write a function that returns an integer that appears most frequently in the array. Assume that there will always be a single one. There's no tie, there's no repeated, and the input can be a nested array of integers. And we got an example. Whenever you have one of those, make sure you have some drawing software at hand before the interview, because one of the most useful things to do here is to try to visualize the problem. Perfect. So this is our input, as we see, and then there's our output. And now we try to somehow mentally make a mapping on how to get there, like a pseudo code, but not really. We just like get a rough idea of what's the input, what's the output. So we see it's a nested array, and then we actually go into the array and count all these elements, right? So we have a 1 that it's actually there twice, right? I see there's a 1 here and there's a 1 here. Then I have 2 that's there 1, 2, 3 times. And then 3 also repeats itself twice. And that's why I remember the 2 and the frequency.
So we got a 2 that's repeated itself 3 times.
Exactly. And so basically, if we look at the problem, you always want to try to simplify also. Because right now we have a nested array. The first simplification I would do mentally and solve the simpler problem first is to say, well, how would I solve this problem if I just have a non-nested array? I have 1, 2, 3, and a 2. So let me think about it. How would I solve this? And what we see here is that we could probably have some sort of a double for loop. So I would go through this array in that direction with a for loop. I'll get each individual element, and then I'll try to see, is it repeated at the right hand? Let's say 1 is repeated 5 times. And then maybe I could store that somewhere. With a double for loop, right? I'd take my 1, and then I would make a second loop and go through each one of those elements and add 1 to my count, and then store that in an object and say, you know what, for the element 1, my accumulator was basically 1, because that's the minimum.
I want to stop there for a bit. You would use an accumulator.
Yes, I would probably need to store this somewhere because they're asking me for the number that's most repeated. So I need a way to store this. So right now, a double nested for loop would work. That would be my brute force solution for the simplest case. But we see that the array it can be nested. So then probably what would be wise to do is to either recurse somehow. So whenever we find an element that's an array, call the function again, or flatten the array as an intermediate step to our problem.
I guess I'm more inclined towards a flattening, where you basically eliminate the nested arrays and you have one array that contains all the elements.
Sure. The only difference here would make it's the performance. And also, I would always implement the solution you are most familiar with. So ideally, you do know how to flatten an array. You cannot use loader, so you'll have to do this manually. And if you don't, then go for the other solution. That's kind of what I have in mind.
Just to clarify a bit, you said a double nested for loop, and I think for me it's not easy to visualize this. I do understand the first for loop you were proposing, basically having an accumulator and going through all the elements and storing kind of the frequency in the accumulator. What would be the second part of this?
Well, the outer for loop is that I need to do exactly that for all the elements. First, I have one for loop that goes to the 1. Then it would go to the 2. And then I have a second one when I'm at the 2 that goes to all the other elements and counts the frequency. Imagine I have my array here, 1, 2, 3, and 4. What I would need to do to figure out if, actually, let me add a repeated element here. If I want to find out how many times these elements repeat themselves, I'll have a first outer loop. I will be the 1, and I will go through, I'm in the outer loop. Let's say I, it's equal to 0. So my current element is the 1. And now inside this, I have another for loop that, let's say, start at j, that's equal to y, and goes through the 2, the 3, the 4, until it finds another 1 and increments. So it is a nested for loop, because then I will have to stop and then go to the 2, do everything again. Then go to the 3 and do everything again. Go to the 4, do everything again. So the time complexity, the number of operations here would be n, as n being the length of the array, by n again. For each number, I need to check all the other numbers and see if there's a duplicate. So that would be my first solution. This would work on a non-nested array, and for a nested array, we might need to flatten the array. So a brute force solution would be, number 1, I will flatten the array, and number 2, I will just run this kind of nested for loop. That's our brute force. Given that it's a live coding interview, the first thing I will do is to run and implement the brute force. So I'm going to go over here and start going with it. So first thing we want to do, let me make this bigger. And by the way, I think we will add this in the description so people can try the problem themselves before you see me doing it. It's different when you have to do it. And so here we said we're going to flatten the array. And second, we want to count the frequency. I'm going to disable Copilot because it's going to solve the problem for us. The other question would be, how can we flatten an array? So imagine we have an array, has a 1, then it has another array inside, it has a 2, and then let's say we have another element that it's another 1, and we have this. So how do I transform this to the flatten without using any helper? So basically, let's try to think a bit about it. We would have an iteration. This is a number, so there's nothing to do. And here we found an array. And whenever we find an element that's an array, we could actually either use the constructor or have a flatten helper and call the flatten on this one. And then we end up calling the flatten on this one. So we will have some sort of recursion where I basically say, hey, flatten this array, like flatten any array, that's my base case, and return always a 1-level array. So I say, and then I have this input to the flatten function, and I know because of how the flatten function works, it will return this 2 and 1. And then I deconstruct that next to the 1, and I end up with a 1, 2, 1. This one is a bit harder to understand. It's an actually recursive problem, but I'm going to make it simpler. I don't want to get to recursion, and I will use a while loop. And I'll just say, I will just go to the array, and whenever we find an element that is an array inside it, then yeah, we could probably solve this with a while loop too. Now if I think about it, it can definitely be done with a while loop, but I'll go with the recursion implementation first. So let's try to do it. And so we said, hey, we want to flatten the array. So how would we flatten the array? Well, I'll probably create a new array that is called flat array. And this would be just calling flatten on my input. And then I'm going to define this flatten function. So function flatten, it takes an input nested array and it returns a simple array. So what does this do? Well, it's going to have some sort of a, let's say, constant. I'm going to use some constants here. Maybe we can get rid of them. This would be my new array, that it's an empty one. And then we're going to go with the for loop, y is equal to 0, y that's less than the input. You want to write those things like, if I wake up in the middle of the night, you can write for loops. If not, interviews will be very painful and almost impossible. Perfect. I'm going to make this an array of number to make my type pass. So what's the problem here? Yeah, I'm not returning anything. That's why it's crying. So let me return like that. Perfect. So we have our new array, and we want to say if the current element it's not an array, so not array dot it's array of the input at I, then in this case, everything is pretty straightforward. We just push that to the array, right? There's nothing to change. Just push it. The array of I. Perfect. The input. Yeah. Our input of I. Else, and this is when it gets complicated. What do we want to do? We want to flatten that array and then concatenate to new array. So I'm going to say constant flat. It's equal to, this is recursion. So I'm flattening because this can be another nested array and another one. So I'm going to go inside and all the time flatten it. Now, why is this a type error? No, that's not signable. So number or nested array is not assignable if, but I would assume that this is always, TypeScript should know that if I call this array that it's array, that the conditional, like TypeScript doesn't realize that input I, it will always be an array. Okay, let me repeat this condition. Maybe the type checker will be smart enough to understand that if I do this of input of I, then I shouldn't have this error as nested array. Okay, I'm doing some very strong type check, but don't worry, most of these interviews will happen in JavaScript. I do them in TypeScript because it forces you to think about the data structure.
Can't you have like a conditional type or?
Yes, of course, but you don't want to get into those. You might get errors. The easiest way, just type queries and move forward. And now we want to combine. So we could say, let me make this a let. And we're going to say, you know what, my new array will be equal to my old new array and my deconstructed flattened array. Okay, now let's see why. A new array should be an array of number. Okay, and now we're getting a kind of, the flat. And here I'll say as number. This is kind of weird that doesn't pick it up. Perfect. And now we return the new array. So that would be our flatten. This itself could be a problem for a coding interview. That would be our flatten problem. I would recommend you take this as an exercise. and do this a couple of times and write this super fast, because there's so much in here. And also like try to figure out a way to do it without deconstruction with a for each loop here, because there's so much in this, and it's a very good exercise for people that are interviewing to make it fast. So once you know how to do it 10, 20 times, once a day, until you get good, until it's muscle memory almost. We flattened the array. So let's go ahead and do the rest of our implementation, which was, let's go with this double for loop and add those things to this memory store. So this is a trick that's very common, which is we're going to have what we call a frequency map. And this is just going to be like an object, and we increment by 1 whenever we find an occurrence, right? Whenever we find an occurrence, we will increment by 1. So I'm going to go with the for loop, let y is equal to imp 0. And then we have our stop condition, which is that y it's less than input.length and y plus plus. And then we go over and say, if the number, it's not in the frequency map. So if frequency map of my input of y, it's not there, because if it's already there, we already counted the frequency once. Let me add a type. So this would be a record, and we mentioned we're gonna have 2 numbers basically. Okay, so we use the flat array, perfect. So if the number is not there anymore, then what do we want to do? We want to add it and then run a nested for loop to count occurrence. So basically we want to say that frequency map of flat array of y, it's equal to 1, because I already found it once. And now I'm gonna check if it's still there. So basically, let's go back here. Like I added a 1 once. I said, hey, I already found you once. Now let me go to all the other elements and see if I find you again. How many times? So then I can say for let j starting at y plus 1, because I already added an element. And then I can say j, it's less than input.length again. And then I would say j plus plus. And I can say, hey, you know what? Then go in, and if the input at j is equal to input I, then increase the frequency map at, actually, I should be using the flat array everywhere, not the input array. Frequency map at flat array of y should be equal to itself plus 1, because we found an occurrence. That should be enough to give us a frequency map. And now the last problem is find the max in the frequency map. So basically we have this, but there's like many of them, and we need to find the max frequency. We can probably do this with a for loop over the keys. So I'm gonna say let key max, the key of the maximum, be the first element of a flat array, let's say. So let's say if it was a 1, we're saying that's a 1. And then we could go, let's say constant keys, it's equal to object dot keys of the frequency map. And then we'll say for, again, another for loop. As you see, this is the bedrock of your knowledge. Very simple things that people usually overlook, that they look too simple, but they are not. Definitely they're not simple to do under pressure. And here I can say if the frequency at the key max it's less than the frequency I find at I, so it's less than the frequency map at keys of I, then make my new key max, and key max it's equal to keys of I. So what is this? It's an any. This should be like a string, like a number array or key or string array, I would assume. Type string is equal to number. It's a string now. So the key is a string. I'll say a string. Oh my God. So give me a second. As the problem with TypeScript, sometimes you got to work around it. So frequency map, 1 second. Okay, let me make this a number. And what is this? This will return an array of strings. So the keys are strings. This is so weird. So we know that keys of I. Okay. Let me make this an array of numbers. And then it will like cry about it. Then I'm gonna do something very nasty. This is one of the things that you're gonna hate about TypeScript, that even if your code makes total sense. So I'm gonna take the key and just run a parse int on it, assuming that all the elements in the array are integers. So now I have numbers. I see the key of the max, it's actually equal to the new key. And finally, I return a key max. That's my key. And the frequency map of that key. Oh, that was a lot of coding of the key max. Okay, so as you see, it's a lot of code. I didn't run the test. Let me run them really quick and see what do we get. Okay, so I have some failing tests. was a 2 and a 4. It is here, A1 and the 2. I have to check test cases myself.
Probably the edge cases that are failing. Should return the first number in case of a tie. That's something we haven't covered yet.
Yes, exactly. So I think that's the main problem right now.
Should
Because I would assume
nested arrays and return the most frequent number. It depends on how the test cases are written. If they
this is an empty, yes, most frequent deeply nested array. So 2 and the 4, 3, 1. So let's see what happened here. We have the 1, 2. It's like 3 trees.
There's a mistake there, right? I mean, I see.
Yeah.
There's a mistake there in the test case.
There's a mistake. We should have another 2 at least.
Yes.
And then the tie one, I can eliminate it. I wrote this very fast, but you see, it's a good thing to know how to review a test. They want to give you a test in the real interview. So running there now. I would assume there's still one that fails. Should be handle nested arrays, and this would be should handle nested, should return the most frequent number. So this is a 2 3 times. This would actually work, right? It's like a 2 3 times, and it returned the 1 3 times. Yeah, because it's a tie. So the 1 was the first element. Okay, and the 3. Yeah, it's always when it's a tie. I think that's like the test cases were not optimized for a non-tie case. It's a case of a tie.
I don't understand the tie because there you have, maybe the first one, right?
Here we have a tie.
That's a tie.
And my implementation returns a 3 in the
yes.
2. So if I go ahead and I just do 2, it will probably work because there's no tie anymore.
And we can, okay.
2, so I return the 2 3 times. Oh yeah, but the output of this should be the 2 3 times, right? If we look at the problem definition.
Yeah, if you change the test case, you gotta change the expected output too.
Yes. Now, the next thing you want to do here is big O notation, kind of analyze the complexity. And
do you want to run the test again to make sure it will pass and close that up? Because you changed the expected output.
Mm-hmm.
Yes, awesome, good.
We will add a link and I will give you the corrected test cases to everybody trying this problem out. In terms of big O notation, we should actually go line by line and analyze it, but I'm only going to look at the lines that grow. You want to make sure your big O, it's pretty solid. It's one of the easiest topics, but it's also super overlooked. So this would be kind of for loop. And then if there's an array, we go again. So this would be, in terms of time complexity, there's no, like memory complexity, it's n because we create a new array with the same length. So time complexity, it's also going to be n as the number of elements, including the nested array. So think of the array as a nested tree is the number of nodes. So basically as many elements as you have, because we literally have to iterate to each one of them and return it. And in terms of space, this will also be big O often because we are storing that new array. We could probably optimize this and make it in place so we don't have the space complexity. I'm going to take this with me to here. So that's ON and N. Now, let's count so we are creating this frequency map. In the worst case scenario, this frequency map, imagine there's like no element is repeated. The frequency map size, it will have as many keys as elements in the array. So this adds another space complexity of n, like memory complexity. And then we have this for loop, which is a nested for loop. And that's when it would be n as the total number of elements squared in the worst case scenario. O(n), yeah. Because I think it's actually going to be divided by 2 because we go to the array and only if the element wasn't counted before we count it. But in the worst case scenario, yeah, this would be like a n square. And then we have this one, which also it's another for loop. So it's the same. In the worst case scenario, this would be O(n) because we iterate over the whole keys to extract the maximum. The dominant term, which is the one that's only the one important, is this one, n square. And this is when you want to get into performance talk and probably won't have a time to implement another solution, but there is at least 1 or 2 solutions you can implement to make this also n. Because at the end of the day, the big O complexity of this would be, let me just sum it up. It would be, in terms of time complexity, it was ON plus ON and plus ON square. So but we only keep
flattening the array, then it was the frequency map that also scales, and then it was the double for loop.
Yes. No. So that's it was this double for loop. But there's a way to probably make this. There's 2 ways to make this problem a lot simpler and probably to go get the complexity down to ON. The number 1 way would be to have not a nested for loop and just whenever we go to the element, if we find it, if it's not in the flat map array, we're just going to add it. So we say, hey, you're already there. And if not, it means it was already there. We just increment it by 1. So I don't need to make a nested for loop. The nested for loop is just kind of the first idea that comes to mind. Okay, I'm going to run the test. And this is not a nested for loop. It's a single for loop. So what I'm doing is I have my memory. I go to the array. If I find an element that's not in my frequency map, I add it and I put the frequency 1. And if I find the element, in this case 1, right, that was already there, I take the 1 and I sum it again, another 1.
Instead of counting again and doing the same, the nested loop. Yeah.
Yes. And now the complexity, it's actually ON. And what we have, like going back to our equation, because we use that dominant term, we are going to have ON plus ON plus ON, but in big O, the multiplication so TON, it's actually ON. So that will be the time complexity.
Because it scales linearly. It doesn't matter what you have. If it's not a power, if it doesn't, it's not exponential, then it's ON, right?
Yes. And I do not think you can solve this in less time than that. We could have a more elegant solution for sure. There's at least one solution that comes to my mind.
What would be your advice to a developer when faced with this kind of problems?
So number one, you want to understand the input and the output, and you want to visualize the problem. That's already half of the work. Once you visualize the problem, most problems for the brute force will be a combination of for loops and while loops. You don't even have to do recursion. I recurse for the flattened array, but you can solve that with a while loop. The problem is most developers, they might know how to write the for loop, but they don't know how to write it fast and under pressure. And what they don't know is how to combine those things really fast. Okay, I need a for loop here, then this output. So kind of have that mental muscle. And it's very easy to get that muscle. It's just going, and it's super boring. It's like going to the gym. You take the flatten thing that I did, and you try to implement it every 3 days. Your memory, short-term memory will disappear. And it's like a muscle. And you learn how to type it out too, because you need touch typing. Everybody that comes into the mentorship of the senior dev, we start with touch typing. And without touch typing, you are nobody. You don't have to be like at 100 BPM, but 60 is the minimum. So if you're interviewing without knowing those things, it's going to be very hard for you to get any kind of success. Once you know those things, it's just a matter of practicing. And the biggest mistake we see people doing every day is they would go down the lead code kind of rabbit hole. They'd go down and do problems that maybe Google asks, like dynamic programming, which is like, I think Google is the only company, one of the few companies that even asks those kind of questions. And they waste a lot of time in those, but then they don't know how to solve these ones, which are relatively simple if you know for loops. The other thing is you got to know very well big O complexity. The good thing is it's usually really easy. It's just kind of seeing the number of operations. And the other thing is be very good at communicating your intent. Write pseudocode and speak out loud all the time. I've never went silent during the whole interview. And that's not something I do actively anymore. That's just when you give me a problem, the first thing I'll do, I'll write pseudocode and I'll start talking about what I'm going to do.
What do I do if I get stuck? I mean, suppose I follow all these steps, but I go blank.
The reason why people go blank in coding interviews is because they either didn't visualize a problem or they don't start with the easy part of the problem first. So one of the tricks that you can use there, it's identify the edge case. Identify, for example, in this case, I did not did it, but what if the array was empty? And just write that one. If empty array, return null. And you'll think that's very simple and it's not going to get you anywhere, but you're already writing code. So the coder block, it's broken. And then you go back, you visualize the problem, and you try for loops, nested for loops. You might, the only peculiarity there is if you see yourself, you get to a point where you're like doing for loops and you identify that you need another nested for loop and another one, and you're like, I cannot type this. That's because you need a recursion or a while loop, because you cannot type all those for loops because you don't know how deep you need to go. And if you know those things, I think you'll do fine in just 95% of those coding interviews for the average senior position. It's a different story if we go into big tech.
And that's a very important lesson. You got to pick your battles. You cannot, if you have 6 months or 1 year to invest in interview preparation, and even after that, people, getting a job on one of those FANGs, there are so many variables involved, which is why one of the things that we do with the people we coach is to actually build a strategy that's adapted to their goals and also to the time they have. So that's something you have to ask yourselves. Is it worth it for me to learn dynamic programming if I'm not going to interview for Google? For the people watching us, if you are interviewing right now, if you are interested in finding out your interview readiness or your technical gaps, there's a link in the description. Actually, there will be 2 links in the description. One with the GitHub repo, so you give it a shot yourselves and you do these things yourselves. And number 2, with a free technical assessment button I put together to find out, where you're at respect to a senior level and what your technical gaps are, which is probably the most important question to answer before you start investing in any kind of training yourself or using a service like the one we offer. With that being said, Bogdan, thank you so much, and stay posted because Bogdan and I have a full list of interview questions that we're going to be solving like this